Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem. Problem 1910. Remove all occurrences of a substring. In this video, we're going to share two solutions. So one is based on the idea of stack, and the other is to practice the the built-in function called replace or replace method of a string. So basically, we are given two strings, s and a part. So we want to continuously find the leftmost occurrence of the substring part and remove it from the whole string s. And we want to return the result string after removing all occurrences of this part. So if you look at example 1, so you're going to get DAB, right, as explanation. Similarly for example 2, so you have 4y's, you have 4x. Afterwards, you are going to get first divide this x, delete this xy, and then this pair, and onwards. So after all, you're going to get AB, right? So this problem is actually rather easy. The reason is that the size is very small because as the length is bounded above by 1000. So with that said, I guess we're not going to go too deep, like using KMP algorithm for string matching or search. So here we're first demonstrate one version using the idea of stack, and then I'm going to introduce to you the replace method of string. First, I'm going to get m. M is the length of the part, right? So I'm going to compare lists. So I'm going to make it a list, but you can keep it a string. That's also okay. And then I'm going to have a stack. So I will just like it. Then the element, number of elements in the stack. So I'm going to call it the original 0, right? So this n elements is going to count the number of elements in stack. So only when the stack has no less than n element, so we need to compare with the reference, and then to check if we need to delete all those. And then we're going to iterate for character in s, and then what we're going to do, we stack append this character to the stack, and then we are going to increment n elements. It's incremented by 1, and then we want to compare. So if the current character equals the reference, the last one, and then we need to do some comparison, and also stack. So actually, we don't need even this part, but let me do this. If n elements is greater than or equal to m, and the stack the last m elements, so I'm going to use negative m onwards, right? So if this equals the reference, so what we are going to do is we're going to set stack equals stack, so up to negative m. In other words, we do not include those. So the number of elements actually is decremented by m, right? Because we popped m elements. So I guess that's it, right? So afterwards, what we need to do is just need to return jump of the elements in stack. So this is the one full solution. Let me first do a quick test. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes all the generic cases. So now let me do some printing in order to digest this. So let me add some I, right? Enumerate s, right? So then I want to print I equals, and then here I'm going to have a look at stack status, And also, I guess I want to get the n elements. Let me print some empty space. So now let's look at example 1. Right? So when I equals 0, you add D into the stack. When I equals 1, you add A to the stack. I equals 2, you add another A. And then when I equals 3, you add B. When I equals 3, also you say 0, 1, 2, 3. When I equals 4, so you first add C to this one. But you know, in this case, C is equal to the last element in the ABC, right? Then we compare all, these are the same. So we are going to do pop operations after we put C in, right? So you can see we have A, B, and C. We just pop these 3 elements. Then after 4, we get DA. And then we add B, and we add A, we add another A, we add B. Then again, we are going to have C. We are going to pop these 2 ABs. So we get DABA. And then we are going to have B, we get this one. And then again, we are going to have C. We are going to pop out this ABs. So we are going to have DAB. Then we join them, we get DAB. So this is for example 1. So you can also see the result for an example 2. So first you have A, you add it. You have X, you have another X, another X. So now you are going to have Y. So Y, because it matches the last element in part. So I'm going to pop this X, right? So we have this one. Then again, you are going to have Y and matching the last. So we're going to pop this X. So we are going to have this one. And then again, we have Y, right? So we are going to pop this X. So we're going to have AX. And then we have another Y. Pop out this X. We are going to get A. And finally, we have a B. So we just put it on the top of the stack. So that's the final state of the stack. Then we just join them. We have AB. So you see the elements. So in other words, the length of this stack matches the number of elements. In other words, when I do the indexing, it's I'm doing it right. So this is the one way to do this problem. In other words, we are using the idea of stack, right? So though I write stack as a variable name, we are not in a rigorous sense using the stack behavior, but actually it indeed like that. So this is the one way. Now let me comment this one. Let's copy this one and change this one to be version v1. So what I want to show you is replace method. String replace method. So here, what I'm going to do is like this. So we are going to check while part in S. So actually, this check, it actually takes some time, right? It involves the length of the S and the length of M. So you can, if you use KMP algorithm, so actually the time complexity will be O n plus M. N is the length of S, M is the length of the part. But I don't want to expand here, or I don't want to go into too deep in this video for this simple problem. So while part is in S, so what I'm going to do, I'm going to update the S. I want to replace this part with an empty string. So I just want to replace one instance, and that is to the very left. So this is exactly the requirement for this problem. So once we get this, then we just need to return the final state of this S. So we can do a test. Yeah, it passes the 2 cases. Now let's submit. Yeah, actually it's also very fast because it's optimized in the implementation. So now you can also do some printing. So round ID, right? So 0. And then we can print round idx, and also we can print s, right? We can do something like this, maybe. I'm going to comment this out, just delete it, and then I'm going to do after round here, state of s. So I'm going to write like this, just like this. So let's print it out. So if you look at example 1, after round 0, so because you delete one ABC, you are going to get DA, BAA, BC. That is, right? Then, so here I guess I didn't increment that. Let me round IDX increment by 1. That will be better. So yeah, after, so here because initialize is 0, and each time I do 1, I just call it round 1. Or you can, yeah, that will be fine. Just 0 or 1, or shifting by 1. Let's see. Yeah, after your first deletion, you get this, and then the second deletion, you delete this ABC, right? You are going to get DA, BA, and BC. And then you delete another ABC, you're going to get DAB. So this is for example 1, I guess. So for example 2, right? So after first deletion, you're going to get A 3x 3y with B, and then 2x to 2yb, 1xy, and 0xy. And then it's the return. So let me recover the short code for this problem. So yeah, let's submit that. Oh, this originates 100%. Let me see. Yeah, anyway, so yeah, that's basically about it for the current video. Thank you for watching.